Welcome to this FP2 video on series solutions of differential equations. So we can use Taylor series to find series solutions of differential equations that can't be solved in other ways. And this will help us find approximations to find solutions that cannot be expressed using elementary functions. So suppose we have a first order differential equation, so something of the form dy by dx equals f of x and y. And we know that the initial condition is that x equals x0 and y equals y0. Then we can calculate dy by dx by substituting x0 and y0 in. So notice this notation. This is to denote the value of dy by dx when x equals x0. Okay, and then we can basically have successive differentiations of the original function and find the values of like d2y by dx squared when x is x0 and d3y by dx cubed when x is x0, and so on. Okay, by substituting previous results into derived equations. Now, the series solution to the differential equation dy by dx equals f comma y is found using a Taylor series expansion of the form. So this is the form that we're going to be using. So y equals y0 plus x minus x0 dy by dx x0 plus x minus x0 squared d2y by dx squared x0, and this is over 2 factorial. And then you could probably guess what we're going to have next. X minus x0 cubed over 3 factorial multiplied by d3y by dx cubed when x is x0, and so on. Okay, so that is the expansion form. Now, when our x0 equals 0, this is going to reduce to the Maclaurin series. So this will then become a much more straightforward series. So it'll just be y0 plus x times dy by dx plus x squared over 2 factorial d2y by dx squared plus x cubed over 3 factorial d3y by dx cubed, and so on. Okay, now I called in the last video the two different Taylor series A and B, so I'm going to call these C and D. Okay, so when I'm talking about them, I'm going to be talking about C and D. Okay, so this is obviously for first order, but second order and higher differential equations can be solved in the same manner, and you'll see that when we look at the examples. So what I'm going to do is I'm going to do an example when x0 equals 0. So I'll do an example, then I'll give you a couple of questions. And then I'll do an example when x0 is not equal to 0, this one. And then, I'll do that example, and then I'll give you a further 2 questions of this style to try. Okay, there's plenty more available online, and if you are working through the FP2 textbook, I think there's like 11 past paper questions in this bit alone. Okay, so lots to try, but obviously in this video just want to give you kind of the basics to get you going, and hopefully completing this video then you can go on and complete other questions and really nail this down. Right, without further ado, let's jump into the first example. And here it is. So find a series solution in ascending powers of x up to and including the term in x to the power 4 for this differential equation. So because we've got to go up to x to the power 4, and we're going to be using equation D, which is this one here, then to go up to x to the power 4, you can see x to the power 3 is the third differential, third derivative, so I'm going to need to go to the fourth derivative. Okay, so I'm going to need to differentiate this 2 times. Now I'll just get rid of this and we'll start. So differentiating, we get d3y by dx cubed equals 1 plus 2 dy by dx. And then differentiating again, I get d4y by dx cubed equals 2 d2y by dx squared. And I've also originally got the d2y by dx squared equals x plus 2y. So what I'm going to do now is I'm going to substitute these in to here to give me this one, and then substitute into this one, and then substitute into this one. So if I substitute what is basically x0 equals 0, so I'm substituting x0 equals 0, y0 equals 1 into, this d2y by dx squared. But I'll just rub those out for now, because I don't really need to put those there. So d2y by dx squared is going to be 0 plus 2 times 1. So it's just going to be equal to 2. Now, what I want to do is substitute into this next one. Okay, and this one I just need to substitute this in. Okay, so in terms of terminology, this can be written as x0 equals 0, y0 equals 1, and dy by dx of 0 equals a half. And that's what I'm substituting in. So this one is going to become d3y by dx squared equals 1 plus 2 times a half. So this is going to be 1 plus 1, which is also going to be 2. Now I need to substitute into this one, d4y by dx to the power 4 equals 2 times d2y by dx squared, which is 2. So this is going to be equal to 4. Okay, so now we need to use the Taylor expansion where x0 equals 0. So, that d1. I'll put it back up now. There we have it. Okay, so I'm just putting that up there in blue for your benefit. Obviously, I wouldn't bother writing this out. So we've got y equals. Now y0 is 1 plus. Now we've got x times dy by dx of x0. So that's going to be dy by dx of 0, which is this one. So it's going to be a half x plus. Now d2y by dx squared is 2. So 2x squared over 2 factorial plus. Now the d3y by dx squared is here. It's 2 as well. So it's going to be 2x cubed over 3 factorial plus 4x to the 4 over 4 factorial. Obviously this would keep on going. So we've got 1 plus a half x plus x squared plus, now 3 factorial is 3 times 2 or 6, but cancelling with the 2 on the top gives me 1 over 3 x cubed plus, now 4 over 4 factorial, the 4 will cancel with the 4, just leaving the 3 times 2 times 1 on the bottom, which is 6. So 1/6 x to the power 4 plus, and then that would continue onwards. So that there is now my solution, okay, my series solution of this differential equation here. Hopefully you found the beginning of this video okay. If you have and it's useful, hit that like button. Don't forget to subscribe if you're yet to subscribe, and if you're willing and able to help me out, please hit that join button. Otherwise, let's look at the first 2 questions. So here are the first 2 questions to have a go at. These are both when x equals 0. Okay, don't forget to stay tuned for what we do when x does not equal 0 in the beginning, so that x0 does not equal 0. Okay, so pause the video now. Welcome back. So hopefully you managed to get these done okay. We'll look at the solutions before moving on to the next example. So here we have our differential equation at x0, x equals 0, y equals 0, and dy by dx equals 1. We need to use the Taylor series method to find powers up to x cubed. Okay, so we've got d2y by dx squared. We need to find the third derivative for the x cubed. So we just need to differentiate this one more time. So I'll put the d2y by dx squared, and that is obviously 1 plus x squared times it. And then we've got x times dy by dx equals 0, because we'll need to substitute into that in a moment. Okay, so first let me differentiate this and then multiply by this, because this is product rule. So this is going to be 1 plus x squared times d3y by dx cubed plus. Now I've got to differentiate this and leave this. So this differentiated times by this. So this is going to give me 2x d2y by dx squared plus. Now differentiate this times this. So it's x d2y by dx squared plus. Now this differentiated times this. So this is 1. So it's just dy by dx equals 0. And that, you can see that these two will collate. So we've got d3y by dx cubed multiplied by 1 plus x squared plus 3x d2y by dx squared plus dy by dx equals to 0. So now let's do our substituting. Okay, so when x equals 0, we get 1 plus 0 squared d2y by dx squared plus 0 times by 1 equals 0. So I've just got d2y by dx squared equals to 0. And then substituted into this one, we've got 1 plus 0 squared d3y by dx cubed plus 3 times 0 d2y by dx squared is also 0 plus dy by dx, which is 1. So that's going to give me d3, sorry, one arrow there, y by dx cubed is going to equal to minus 1. Okay, so now all I need to do is substitute this into my d equation, expansion. So y equals, so y0 is 0 plus, and then I've got my first dy by dx is 1, so I've got 1x plus, now d2y by dx squared, that's going to be 0 over 2 factorial x squared plus my third one, that's going to be minus 1, isn't it? X cubed over 3 factorial. And this is obviously going to go on, but we don't need the rest. So we've got x minus 1/6 x cubed. And that there is the series expansion of this differential equation. Just x minus x cubed over 6. Let's have a look at question 2. Find a series solution as n to the powers of x up to and including, so x to the power 4. Now we're going as far as, here's my differential equation, x equals 0, y equals 1, dy by dx equals 1. Okay, so I'll do this one. I'll use the full kind of terminology when I'm doing this, but let's do this out, write this differential equation out because we're going to need it for the substitution. So let's differentiate. So this is going to be d3y by dx cubed plus, right, for the next one then I've got this times this differentiated, so it's going to be 2y d2y by dx squared plus this differentiated is going to be 2 dy by dx times dy by dx plus 3y dy by dx equals, no, the one's going to go, so it's just going to be 1 from the x. And since I've got dy by dx times dy by dx, now not to confuse that with d2y by dx squared, this will just be dy by dx all squared. Okay, it's not the second derivative, it's the first derivative squared. So I'm just going to replace that there. Right, now let's differentiate second time. So this is going to differentiate to this. Now let's differentiate this. So we've got 2y times this differentiated. So that's going to be plus 2y d3y by dx cubed plus, now we got this times this differentiated, so it's going to be 2 dy by dx times d2y by dx squared plus, now I've got this one, so this is going to become 4 dy by dx times dy by dx differentiated is d2y by dx squared. Okay, so you're dealing with this like, you know, if you were differentiating something like this, you know, when you bring this power down, take one away from the power, and then multiply by the inside differentiated. Okay, but of course in this case we had 2 dy by dx squared, so bring the 2 down, takes me to 4 dy by dx, and this is the power 1, and then times by the inside differentiated, which is d2y by dx squared. Okay, so hopefully you're all okay with that. Now moving on to this one, so we've got 3y times this differentiated, so it's going to be 3y times d2y by dx squared plus, now 3y differentiates to 3 dy by dx times dy by dx, and that's going to then equal 0. So let's go ahead and sort this one out. So d4y by dx to the 4 plus, now we've got 2y d3y by dx cubed. There's no other terms like that in there, so let's keep that the same. Now I've got 2 dy by dx times d2y by dx squared, and we've got 4 of them here, so that's going to give me 6 dy by dx times d2y by dx squared plus 3y d2y by dx squared plus 3 dy by dx all squared equals 0. So hopefully you got the same thing as me. Now just checking my work back, I noticed when I differentiated y cubed I put 3y, not 3y squared. Okay, so that will have a knock-on effect, as this will be 3y squared, and this one will be, this one at the end will not be that, because it'll be 6y dy by dx, so it'll be that. So it's just slight difference. This is 3y squared, and this one will be a 6y in front of it. Okay, always worth double checking your work before you move on. Obviously I could have deleted that out of my video and gone and did it like perfect, but I want to show you that, you know, you make mistakes as you're doing it sometimes, and it's important to go and double check the question and make sure you haven't made a silly mistake like I did, missing out the squared term there. as it affected this answer and then affected this answer. Okay. Okay, now I've got my three kind of values that I need to work out. And what I'm going to be doing is I'm going to be substituting x0 equals 0, y0 equals 1, and dy by dx when x is 0 equals 1. And I'm going to substitute these into each of my equations. So I think I'll use a green for this. So d2y by dx squared plus 2 times 1 times 1 plus 1 cubed equals 1 plus 0. So this is going to be 2 plus 1 is going to be 3. 1 minus 3 is going to be minus 2. So d2y by dx squared is going to be equal to negative 2. Now, substituting into this one, okay, I'm going to be substituting, I don't have any x terms, but I have a y term. I have a dy by dx when x is 0 term, and I have a d2y by dx squared when x is 0, and that is equal to minus 2. Okay, so that is what I am substituting in. So I've got d3y by dx cubed is not equals, going to write equals then. So 2 times y times minus 2 plus 2 times 1 squared plus 3 times 1 squared times 1 equals 1. So that gives me that d3y by dx cubed is equal to, so I've got minus 4 plus 2 is going to be minus 2 plus 3 is going to be 1. 1 minus 1 is going to be 0. So d3y by dx cubed is 0. And then substituting into my final one, I've got y0 equals 1 is going in. dy by dx when x is 0 equals 1 is going in. d2y by dx squared when x is 0 equals minus 2 is going in. And d3y by dx cubed when x is 0 equals 0 is going in. Okay, so that's what I was talking about with I was saying the full notation. Okay, saying what I'm substituting in each one. So this is going to be d4y by dx to the power 4 plus 2 times 1 times 0 plus 6 times 1 times minus 2 plus 3 times 1 squared times minus 2 plus 6 times 1 times 1 squared equals 0. So d4y by dx to the power 4 is going to be, so this is 0, this is going to be minus 12 multiplied by, added to, so we got 3 times minus 2 is minus 6. So 12, minus 6 is minus 18. Plus 6 is minus 12. And sorry, that's minus 12 on the same side as this minus 12 equals 0, so this is going to equal 12. So those are my values. All that's left to do is to substitute it into my series. So that is y equals 1 plus, now it's 1x plus minus 2 over 2 factorial x squared plus 0 over 3 factorial x cubed plus 12 over 4 factorial x to the power 4. So that is y equals 1 plus x minus x squared plus 0, and then 12 over 4 times 3 times 2, so that's going to be a half x to the power 4 over 2. And that there is my series. Hopefully you found the video again useful so far. If you have, don't forget to hit that like button. But now let's move on to the second example, when x doesn't equal 0. So the start is just the same. So I'll write down the differential equation because we will need to substitute into that shortly. And then we need to differentiate once because we need the third derivative, of x, not differentiate 3 more times, So d2y by dx squared differentiates to d3y by dx cubed plus 2 d2y by dx squared plus, now this is going to be, differentiate the 3x first, so 3y plus 3x, and differentiate the y, dy by dx. So there I have my two equations, and I'm going to substitute. Let me just move these down a little bit, but I'm going to be substituting in x0 equals 1, y0 equals 1, and dy by dx, where x is 1, and that's equal to minus 1. So that's what I'm substituting in. So d2y by dx squared plus 2 times minus 1 equals 3 times 1 times 1. So that is going to be d2y by dx squared equals, so this is minus 2 and this is 3, take the minus 2 over and we get 5. So now in the second equation I've got an extra term to substitute it in, so we get d3y by dx cubed plus 2 lots of 5 equals 3 times 1 plus 3 times 1 times minus 1. So that is going to be, we've got 10 on this side, and then we've got 3 plus minus 3. They're going to cancel out. So this is going to be equal to minus 10. So now I have all my values from, x equals, x0 is 1, y0 is 1, dy by dx when x is 1 is minus 1, and we've got the second one 5 and the third one minus 10. Now we're going to substitute in to our first equation, so I'll put that on the board now. Okay, so this is the one we're going to substitute into, so it's going to be y equals, so y0 is 1 plus, now we've got x minus x0 is 1, dy by dx of x0, that is going to be minus 1. Plus, now we've got x minus 1 squared over 2 factorial multiplied by 5 plus x minus 1 cubed over 3 factorial multiplied by minus 10. So that equals 1 plus, sorry, not plus, minus x minus 1 plus 5 over 2 x minus 1 squared minus 10 over 6, which would be 5 over 3 x minus 1 cubed. Okay, so I'll just rewrite this one to be minus 5 over 3. And there we have it. We've got our solution now, okay, using the Taylor series when x doesn't equal 1. So we've got to use this first equation. So depending on whether x is 0 or x equals 1, just depends on which equation we're going to use. But they are basically the same equation, aren't they? You know, if x0 equals 0, then this is just going to be x times dy by dx, and then x squared over 2 factorial times d2y by dx squared plus x cubed times 3 factorial times that. So it is basically just this equation for both of them effectively. Okay, the other equation is just substituting in x0 equals 0. But there we have it. Right, let's have a go at 2 questions, or let's have a look at 2 questions where x is not 0. So here they are. I've called them question 3 and question 4. Pause the video now to have a go. And welcome back. Hopefully you've managed to solve both of these problems. I'll go through them in just a moment, but just a reminder, if you found the video useful so far, hit that like button. Subscribe if you yet to subscribe, and join. Please join. It'll help me out. Hopefully in the future I'll be able to give more of my time to making videos. Anyway, let's look at them. Solutions. So, usual start, write down your differential equation. And we need to go to the squared term, so we need to d2y by dx squared. So we just need to differentiate this once. So let's differentiate it. So sine x times d2y by dx squared plus, to differentiate sine is cos, so it's cos times that, plus. Now let's differentiate the y, dy by dx times cos x, and now let's differentiate the cos to minus sine x equals 2y dy by dx. So let's just sort this out. So we've got sine x d2y by dx squared plus cos x dy by dx and dy, so this is going to be 2 cos x dy by dx minus y sine x equals 2y dy by dx. So there we have our 2 kind of equations there, our original and the differentiated one. So let's go ahead and, well, substitute in. So first things first, y is root 2 when x is pi by 4. So we get sine of pi by 4 dy by dx plus root 2 cos of pi by 4 equals root 2 squared. So sine of pi by 4 is 1 over root 2, or root 2 over 2. Oh, yeah, root 2 over 2. If I rationalize the third. And cos of pi by 4 is the same. Okay, so this is root 2 times 1 over root 2 equals 2. So we've got dy by dx is going to be, so this is going to be 1. So 2 minus 1 is 1 times by root 2. So this is just going to be root 2. And to kind of put my full, nope, didn't mean to rub it all out, but dy by dx, so pi by 4 equals root 2. So writing it out like that. Now let's go ahead and write out the second one. So sine of pi by 4 d2y by dx squared plus 2 cos pi by 4 dy by dx, which is root 2, minus y. So what was y? Root 2 sine pi by 4 equals, now I'm running out of a bit of room here, so what I'm doing is I'm just going to move this underneath, so I've got plenty of room. So 2 times root 2 times root 2. So that's 1 over root 2 d2y by dx squared plus 2 times 1 over root 2 times root 2, so that's going to be 2 minus, this is going to be 1 equals 2 times 2, that's going to be 4. So 2 minus 1 is 1. So taking away 1, that's going to be 3 times them by root 2. So d2y by dx squared is going to be 3 root 2. And this will be when x0 equals pi by 4. So now let's substitute it in. So we get, I'm going to do it in green then. So we get y equals, so y is 0 is root 2 plus x minus pi by 4 times by dy by dx, which is root 2 plus x minus pi by 4 squared over 2 factorial times by d2y by dx squared, which is 3 root 2. So this is y equals root 2 plus root 2 x minus pi by 4 plus 3 root 2 over 2 x minus pi by 4 squared. And that there is my series solution. Hopefully you got that one without too much bother. Let's have a look at the final question. So this question has been broken down into two parts, part A and part B. And I think in total, let me just check, it's worth 9 marks, this question. Part A is worth 4 of the marks. So we've got to differentiate down to here, and obviously it could just skip this part A and just jump in with this bit. Okay, so you'd have to differentiate down to that anyway. So let us, for A, jump straight in with differentiating it. So we're going to differentiate this. We get d3y by dx cubed equals, so 4x times d2y by dx squared plus 4 dy by dx, you know, the product rule, minus 2, not y, 2 dy by dx. And that is going to be d3y by dx cubed is equal to 4x d2y by dx squared plus 2 dy by dx. Right, differentiating this, we get d4y by dx to the power 4 equals 4x d3y by dx cubed plus, that's 4 d2y by dx squared plus 2 d2y by dx squared. So just simplifying this, we get this plus 6 d2y by dx squared. Right, then the fifth derivative, or my third one, don't know how you want to say it, we get 4x times d4y by dx to the power 4 plus 4 d3y by dx cubed plus 6 d2y by dx squared. And that is d5y by dx to the power 5. My handwriting is pretty bad at the moment. I think in the last few videos, you know, it's definitely not been the best. Let me know in the comments what you feel, if you're able to, you know, see it. Sorry, this should be cubed there. Okay, just let me know how you are finding my handwriting so far. So there we have part A done. Okay, let's move on to part B. So we have got that y and dy by dx equals 2 when x equals 1. So let's substitute these in. d2y by dx squared is equal to 4 times 1 times 2 minus 2 times 2. So this gives me 8 minus 4, which is going to be 4. No rearranging to do this time. So this is going to be 4 times 4. No. X is 1, isn't it? This one's 4 plus 2 times 2. So 4 times 4 is 16, plus 4 is going to be 20. d3y by dx cubed is equal to 4 times 1 times 20 plus 6 times 4. So that's going to be 80 plus 12, 24, so it's going to be 104. So d4y by dx to the power 4 is 4 times 1 times 104 plus 10 times 20. So 416 plus 200, so 616. So plugging this into the Taylor series, we have the first one, y is 2. Then we have dy by dx is 2. So it's 2 times x minus 1, isn't it? Because x0 is 1. Plus, now we've got 4 over 2 factorial x minus 1 squared plus 20 over 3 factorial x minus 1 cubed plus 104 over 4 factorial x minus 1 to the power 4 plus 616 over 5 factorial x to the minus 1 to the power 5. And just simplifying this, we've got 2 plus 2x minus 1 plus 2x minus 1 squared plus 10 over 3x minus 1 cubed plus 13 over 3 x minus 1 to the power 4 plus 77 over 15 x minus 1 to the power 5. And that is now my series solution here. And that brings us to the end of this video. Hopefully you found it useful. I really hope you did. So if you did, don't forget to like, subscribe if you yet to subscribe. I know quite a few people are watching and not subscribed, so please subscribe. And like I repeated, if you're willing and able to help me out financially, hit that join button. Even if it's only for a month, every little bit helps. See you in the next one.